Hello all, welcome to this simulation video. My name is Preeti Chaudhari and I am an intern at Emertxe Technologies. In this video, we will carry out the simulation of microwave oven. In the 4-week internship at Emertxe Technologies, we have built this project along with team members Sarthak Gupta and Shivprasad Suryawanshi. In this internship, we have learnt about embedded systems and carried out the simulation using software MPLAB IDE, XE8 compiler and PICSIMLAB. Now moving further with the PPT. In this internship, we have studied about embedded C, conditions, arrays and pointers, and introduction to embedded systems and microcontrollers. These are the contents of the PPT. We will start with what is a microwave oven. So microwave oven is a device which is used to heat food using microwaves, which is in form of electromagnetic waves. There are 4 modes which can be implemented in a microwave oven, which are micro mode, grill mode, convection mode and start mode. The first mode is micro mode, in which as soon as the power is turned on or we start the simulation, the power is displayed on the screen. The second mode is the grill mode, whereas the third mode is the convection mode. In the convection mode, we will elaborate the concept about temperature. Moving towards the requirements of carrying out the simulation, the first requirement is MPLAB IDE, which is the independent development environment where we can write the code. The second requirement is the XE8 compiler, in which we can compile the code, whereas PICSIMLAB is the software where we can simulate our program. So now we can move to difference between microcontroller and microprocessor. Microcontroller is built to perform a certain or a specific task, and in this case we will use a PIC microcontroller for our simulation. Now we will move on to the various components of a microcontroller. The very first component is the matrix keypad, which will be used as a switching circuit for our simulation. This is the architecture of the PICSIMLAB. Now this is CLCD, which stands for Character Liquid Crystal Display. CLCD is nothing but a display on which we will display our result. Interrupts. Interrupts is a major component which will enable us to run the program by giving regular interrupts. ISR, or the interrupt service routine, is a software routine which is invoked by the hardware in response to an interrupt. Timers. In this case, we have used a 4-bit timer in our simulation to increase and decrease the time. After learning about the components of the project, we will now move on to see the output of the project. Here I have attached some screenshots from the simulation. Here we can see the power on, where the power is on and hence all the 4 modes are displayed. Here we can also see the micro mode where the power is displayed, whereas in the grill mode we can select the timing as per a requirement. In the convection mode we need to set the temperature and there is a preheating timer mode as well. We have the start mode in the last, which is an automatic start mode which has a 30-second default timer. The buzzer goes off once the default timer is completed. Once the timer is completed, we can see the time up on the screen. If we press RB3 key on the PICSIMLAB, we receive a notification that the door is open and we need to close it. Thank you, and this PPT was presented by Preeti Chaudhari, Shivprasad Suryawanshi and Sarthak Gupta. We will now move towards the code overview. The code has been written by 3 members of the team. In the beginning, we can see that all the libraries which we need have been loaded. All the required variables have been initialized accordingly and all the required modules have also been loaded. In the main program over here, we are using the while loop where we have specified all the conditions. All the different keys and their functions have been mentioned as well. Along with this, all the modes are also given in the program. Now, we have used the switch case for determining all the cookit modes and at the end all the functions have been called. In the main header file, we are including all the modules required in this project. Now we move on to build this project and see what happens. You can see that the code was built successfully. Once the code has been built successfully, we will load the hex file into the PICSIMLAB and carry out the simulation. We will now see the output of the project. First of all, we will load the hex file into the PICSIMLAB board. Once the hex file is loaded successfully, we can see power on written on the display, and now we can see the 4 modes. Now, if we click on 1, we can see the power in the micro mode is 900 watts. Now, we can give the timer as per our requirement. I will give a time of 59 seconds to the timer. Now, if I wish to clear the screen, I can click on the star and the screen will get clear. If I wish to proceed further, I can click on hash to enter. If we click on hash, the timer has started and we can see the fan running, which implies that the oven is working. Now, if we click on 5, the timer has been paused and the fan has also been paused accordingly. Now, if we click on 4, the timer has resumed again and the fan has started running again. If we click on 6, the timer has been stopped and so the fan. Now, if we click on 3, we will enter the convection mode. In the convection mode, we need to set the temperature. Here, I will give a temperature of 100 degrees. Now, I will click on hash to enter the timer. After setting the temperature and clicking on hash, we will enter the default timer which is mentioned in the code. This is a 3-minute preheating timer which will prevent the oven from heating up instantly and protect the oven from any sort of heat damage. Now, if we will see the first switch over here, if we pull down this first switch, the LCD display will go away. And if we pull it up again, the LCD display will start again. We just need to ensure that this switch is always upwards so as to see the LCD display. Also, if we turn the buzzer switch towards the right, the buzzer will not go off once the default timer is completed. So we need to make sure that the buzzer is always on. Once we have completed the preheating, we need to enter the time and click on the hash to start. Here, I will give a time of 59 seconds and click on hash. You can see the timer has started and the fan is running, indicating that the microwave oven is in the working condition. We will now stop this by clicking on 6 and move on to the start mode. To enter the start mode, we click on 4. When we enter the start mode, there is a default timer of 30 seconds. If we click on 4, the timer has been increased by 30 seconds. We can pause and resume it accordingly as per our requirement. If we further click on 4, the timer increases by more 30 seconds. We will now move on to the grill mode. To enter the grill mode, click on 2 and we can give a timer of 10 seconds to see its operation. Once you have entered the time, click on hash to enter the timer. As soon as the time is completed, we will hear the buzzer. The buzzer goes off and stops after some time. Now, we will give a time of 20 seconds and click on hash to enter the time. Now, if we click on the RB3 of the tactile switch on PICSIMLAB, The screen will display that the door is open and we need to close it. Along with it, the buzzer will also go off. Now we will click on stop, and now we can see all the 4 modes. Hence, the project simulation is completed. I hope all of you liked this video and understood all the basic concepts. I would like to thank Emertxe Information Technologies for providing this internship opportunity, and I would also like to thank the group members Sarthak Gupta and Shivprasad Suryawanshi. Thank you.